mom used. I got to make it for Christmas or something. All right. Anyway, have 39 done for tomorrow, except for 5 and 7. Take out your textbooks to 160. We'll do lesson 40. Lesson 40. Variation on something that we've already done. Not really a new concept. We're continuing to talk about exponents. Now, quick, no pressure refresher. What do we mean when we have an exponent? Something like x to the 5th. What does that mean? What do I do to x? Right, I take 5 copies of x and I multiply them together. It doesn't matter what the base is. If the exponent is 5, that means I take 5 copies of it and multiply it together. All right, so x to the 5th. Right, that's x times x times x times x times x. What about x to the 1st? What's that? That's just x. It's 1 copy of x multiplied together. All right, great. What about x to the 0? X to the 0 is 1. Always. Anything to the 0th power, I guess except for 0, is 1. I don't know what happens 0 to 0. Got to think about that. All right. What about if we have a negative power? What if we have like x to the negative 3?
1 over negative
1 over x
squared.
Yeah, 1 over x cubed, right? When we have a negative exponent, it means we put it on the bottom of a fraction. You can think of this as being, instead of multiplying that many copies of x, we're dividing that many copies of x. We divide by x once, we get 1 over x. Divide by x the second time, 1 over x times x, or 1 over x squared. Third time, 1 over x cubed. So negative exponents means it's on the bottom of the fraction. Good morning. Welcome back. All right, what if we have something like x squared times x cubed? What do we do then?
X to the 5th.
X to the what?
5th.
Right, so what did we do to get x to the 5th? Right, when we're multiplying two things together that have the same base, the exponents add together. Because this means 2 copies of x multiplied together, this means 3 multiplied together. We multiply all of those together, now we have 5 copies of x that we're multiplying together. So, right. Okay, what if we have something like, what if we have something like this, x to the 4th times x to the negative 1. What would that give us?
X to the 3rd.
Yeah, x cubed, or x to the 3rd. It's the same process. When we multiply, we add the exponents. 4 plus negative 1 gives us 3. If you want to see this done all the way out, we've got x times x times x times x times 1 over x. That's x to the negative 1. Which is going to cancel out one of these x's. We've got x over 1 times 1 over x. Those cancel out. And we're left with x times x times x, or x cubed. So here's the variation. What if we have something like this? What about x to the 7th divided by x squared? What if I'm dividing? Right, x to the 5th. So when we multiply them, we add the exponents. When we divide them, we subtract the exponents. Not too surprising. Again, if you want to see it written out, we've got 5 x's on top. 1, 2, 3, 4, 5. And we've got 2 on bottom. And so 2 of these are going to get canceled out by each other. And we're left with 3 x's multiplied together. Oh, I said the 7th on top. That's why. I'm left with 5 on top, or x to the 5th. So when we're dividing, then the same base and we're dividing, we subtract the exponents. So what if we have something like this? What if we have x to the 4th divided by x to the negative 3? What do we get?
X to the 1, that's x.
X to the 4th divided by x to the negative 3.
X to the 1.
No.
X to the 7.
Yes, x to the 7th. Somebody said it.
Oh, right. Subtract.
Why? Because we subtract. 4 minus negative 3. What's 4 minus negative 3?
Oh, 4 plus.
4 plus 3, right. Now, We could also look at this same problem this way, x to the fourth over x to the negative 3. Yes? That means the same thing. The line in the fraction means divide.
Bring it up.
Right, we had talked about when we have a negative exponent or positive exponent, when we have something on the bottom of a fraction, we can flip the sign on the exponent and bring it to the top. So we could flip the sign on this x to the negative 3 and bring it to the top, and then we're going to have x to the fourth times, oh look, x to the positive 3, which will give us x to the 7. Look at that, that's amazing. That is so cool. Yeah. You know, it's Monday. It's not Monday. It's the first day back from break. I'm a little rusty, you guys. Just making silly errors today. All right. So yes. So we subtract when there's division involved, and it could be, you know, we could have something like this. Also, we could have x to the negative 3 divided by x squared. What's x to the negative 3 divided by x squared?
X. Oh, and negative 1 over
Here, let me write it this way. X to the negative 3 divided by x squared. What are we going to have?
x to the negative 5.
Either we could write x to the negative 5, or how else could we write that? How else can we write x to the negative 5?
1 over x to the negative 5.
1 over x to the
Fifth.
fifth, right. A negative exponent means the same thing as having the positive exponent on the bottom. So here, again, we're dividing, so we just subtract. Negative 3 minus 2 gives us negative 5. Or we could think of it this way. We could see this negative exponent. You're going to learn that negative exponents are another one of these things that I don't like. In addition to decimals, and what's the other one that I don't like? Oh, subtraction. I don't like subtraction. I don't like decimals. I don't really like negative exponents either. So I see this negative 3 up here. I say, I don't like that. Why don't I just move it to the bottom? I move to the bottom, I get 1, because you have to keep something on the top. This is a type of division or multiplication that we're doing here. And on the bottom, I'm going to have x to the negative 3 times x squared. I mean, x. Man.
I think you should just sit down.
Maybe I should just sit down and like take a break for a while.
Maybe you should lift up your arms. You know, I think
Make some rookie mistakes here. Yeah.
There you go.
Like, is one side of my face drooping or something?
Yeah.
Okay.
You should just have a free period.
That's a good idea.
Hold on, guys. We're almost done with the
It's getting overloaded.
All right.
Sensory overload.
Any questions about that? This I think is pretty straightforward. We're just subtracting the exponents when we got. Okay. All right. Now, but I want you to turn to page 162 and look at example 5, 40.5 on the middle of the page there, because this is something that I want you guys to get familiar with. So notice they give you this big fraction here, and they tell you to simplify it. Here, let's just take it one step at a time. They give us x to the negative 5.
Oh.
They give us y to the 6th z over z to the negative 3
Y2.
y squared x to the
7. The 1.
yeah, just x to the 1. Okay, they say simplify this. Now we know we're going to be able to simplify it. Why? Because we have some things combined with multiplication on top and some things combined with multiplication on the bottom. And we have variables, the same variables in both those places. Generally speaking, we don't want to have the same variable on both the top and the bottom of a fraction. So we shouldn't have x on the top and the bottom. We shouldn't have y on the top and bottom. We shouldn't have z on the top and bottom. So we can combine those x's, those y's, and those z's with each other. But there are multiple different ways we can do this. Notice here that they give you 4 different possibilities. One possibility, look at solution A, is if we bring everything to the top of the fraction. So x to the negative 5, and then we bring this x from the bottom to the top. What does it become?
X. Which one?
What does this x become when we bring it to the top?
X to the negative 1.
To the negative 1, right? Because it's positive 1 right now, so when we bring it to the top, we flip the sign on it. Okay, we've got y to the 6th And what happens when we bring this y squared up to the top? What does it become?
Square.
Y to the negative 2, and we've got the z cubed on the bottom. What is that going to become when we bring it up?
Or well, the Z cube.
Z cubed, right. Okay, and when we simplify this, what do we get? X to the negative 5 times x to the negative 1, we get what?
X to the negative 6.
X to the negative 6, y to the 4, z to the... Okay, that's one possibility. We can bring everything to the top. Second possibility, what they show you in B, is you bring everything to the bottom. Not generally a good idea. Notice, bring everything to the bottom, we just flip the sign on all those exponents. Instead of x to the negative 6, on the bottom of the fraction we have x to the 6th. Instead of y to the 4th, we have y to the negative 4 on the bottom of the fraction. Instead of z to the 4th, we have z to the negative 4th on the bottom of the fraction.
So,
Okay, so one possibility, moving everything to the bottom, you can do it. It's generally not a good idea because why would you deal with a fraction when you don't have to? The other thing that we might do, which is convenient sometimes, is instead of bringing everything to the top, we say, you know, I actually don't like negative exponents. So I decide, I don't want to deal with negative exponents today. I want to make all my exponents positive. So what can I do with this? How can I rewrite it to make all the exponents positive there?
But x negative 6 over 1. I mean under 1.
Right, we move it to the bottom of the fraction. What happens on the top of the fraction then?
To y 4 z.
Yeah, y to the 4th, z to the 4th. Because instead of this, right, we write 1 over x to the 6th times y to the 4th times z to the 4th, which we can simplify to that. That's something else that we might do. We might make all of our exponents positive. Another thing you could do, as they show you an example, D, is you could make all your exponents negative. Not something you're generally going to do.
So is this just like situational?
Yes.
That's what they're asking.
Yeah, so they'll usually ask you either to move everything to the top or to make all the exponents positive. Occasionally they'll ask you to do one of the other ones. But yeah, depending on what exactly we're trying to do, one of those may be more useful than another one. But generally you're only going to be doing either solution like A or C. B and D, not so much. It's good to be able to know how to manipulate these that way, but not generally something that's going to be very helpful. Okay, second thing here is we can use this when we're dealing with the distributive property. So if you look at example 40.6 there, notice that x to the negative 2, let's just do this one on the board really quickly. Distributive property is going to work the same way no matter what is involved in it. 4x to the negative 2 over y to the 4th times y to the 4th x squared minus 3x to the 4th over y to the negative 2. Now, before we do anything else, what should we do?
Call 911.
Call 911. We should see if there's anything we can simplify. Is there?
Oh wait, that's for
I mean x. Wait, are you talking about
Is there anything we can simplify here?
x and x to negative x? The x two. The
Bring it up.
Bring what up?
Y to the 4th and y to the negative 2.
Okay, we could do that, but let's see what's going to be most useful. So there's nothing here like y to the 0 or anything like that that's immediately going to cancel out. There isn't anything like x times x to the 4th that we can combine immediately. So let's move on. Now let's take a look at the problem. What do they ask us to do in example 40.6 there at the bottom of page 162? What's the second part of the directions? Write the answer with all exponents positive. So we're going to be doing something like C, yes.
So you have to take x to the second.
So we can do that now. When they tell you to make all the exponents positive or move everything to the top, you have two options. One, you can either do it as written, which is what they have, and then change into the format that they ask you for, or, which I prefer to do, is we change the format first, rid of all our negative exponents first. What is 4x to the negative 2 over y to the fourth? How are we going to change that to make all of our exponents positive? Do what?
Bring x to the 2 down.
Right, so what is it going to become?
X squared.
4 over,
Y to the fourth, X to the.
yeah, x squared y to the fourth.
Couldn't you also just do this distributive first and then do?
Yes, you could. That's what they do in the book. They do that. They do the distribution first, and then they change the format. I like to change the format first because sometimes, especially if you're doing something like making all your exponents positive or moving everything to the top, which generally makes your life easier, I would do that first. If they ask you to do something like make all the exponents negative or move them all to the bottom, then I would do the distribution first and change the format afterwards, because negative exponents and things on the bottom are going to be more difficult to deal with generally. You're missing a button. Like you skipped a button. You skipped a button here. Yeah. That could be. All right, then this next term here, y to the fourth x squared, do we need to do anything? What can we do here to make our lives a little bit easier, though?
Make them
He's gonna just cross out anyway. If you made them all negative,
what?
you could cross them all.
Well, we want to make everything positive because that's what they're asking us for at the end.
Bring y to the negative 2 up.
No. We're just looking at this term right now. Y to the fourth x squared. What's something I can do to make my life easier? What am I going to be doing in the next step here? Distributing. So I'm going to be multiplying this term by this fraction here, right?
Here.
So maybe I should write it as a fraction.
Yeah.
Just to make my life a little easier. So what would this look like as a fraction?
Y over x squared over 4.
Yeah, just write it over 1. Because the next thing we're going to be doing is multiplying these two together.
And then it'll just be itself, right?
Well, we'll do the distribution next. Okay, and then what happens here with this last term?
Bring it up.
And so what are we going to get?
Y squared. 3x fourth y squared.
And again, let's write it over 1
Over 1.
because we're going to be multiplying it by a fraction. You don't have to do that, but it's going to make your life easier because otherwise, next step, when we multiply them by this fraction, you're going to have to do that anyway. You can always write something as a fraction over 1. You can always do that because it doesn't change the value at all. Dividing by 1, multiplying by 1, you're always allowed to do that. All right, so now let's distribute. When we multiply these two terms together, what are we going to get?
4y fourth squared.
Over?
Over x squared y minus
Minus 12
x to the fourth y squared over x squared y.
Okay. What do we do now?
Oh,
We done?
No, didn't you add it?
Are they like terms?
yes.
Remember, to be like terms, they have to have all the same variables with the same exponents in the same places.
They have the same
The parameters.
denominator. Wait, can't you add it to have the same denominator?
We could combine them if they have the same denominator, but before we combine them, there's something else that we can do here, which is actually more useful. Anytime we have fractions at the end of a problem, what should we try to do with those fractions?
Simplify.
Simplify. Can we simplify these fractions at all?
Yes.
Yes. How can we simplify the first fraction?
X to 2. Yeah.
What is it?
How can we simplify this first fraction? Remember, we shouldn't have the same variable on both the top and the bottom of the fraction.
Oh, yeah. No, you cross them out.
Or it is, you put X 0.
Yeah, x squared and x squared, those cancel out. Or we could think of it as x squared times x to the negative 2 or x squared divided by x squared. Either way, we get x to the 0 or 1. They cancel out. What else?
24.
Y to the fourth cancels out on both top and bottom. So the first term, we're just left with
4.
4. Ooh, look at that. I like that. I like getting rid of that fraction entirely. What can we do with this second term?
Make it X2,
Yeah.
Y negative 2.
Yeah.
So, right, we can do x to the fourth divided by x squared. We're left with 12x
Squared
x squared
over
Over. Yeah.
Y
Over.
y squared.
Over. Yeah. Y
negative
squared.
Because they all gotta be positive.
Okay, so hold on. What happens when we do y squared divided by y to the fourth?
It's gonna be y negative 2.
Y to the negative 2. But what did they tell us?
Gotta bring it up to make it positive. So it's gonna be y squared.
No, it's not gonna do.
If you keep it, if you go to the bottom, and it'll be, if you keep it on the bottom and make it Y to on the bottom.
Right. So we could. This is correct, or this is the right value. Y squared divided by y to the fourth gives us y to the negative 2 because we're dividing, so we subtract the exponents. 2 minus 4 gives us negative 2.
That's the word.
Okay. Yes. Everybody see how we got that?
Yeah.
Y squared divided by y to the fourth gives y to the negative 2. Yes?
Error.
Yes?
Error.
Man, everyone's
Yes.
running at like 40% operational capacity already.
I don't know.
Okay. But, as you pointed out, what's the problem with writing y to the negative 2? What's the problem with writing
It
y to the
does
negative 2?
not fit the parameters.
Right, what are the parameters of this problem?
All variables have to be positive.
Not the variables have to be positive, the what have to be positive.
Exponent.
The exponents need to be positive. So instead of writing y to the negative 2, what are we going to write?
2x2 over y2.
Okay,
12x2 over y2.
please don't say things like x2, y2. It's a general comment for the class. Say x squared, x raised to the second power, x to the 2, whatever.
Okay, 12x squared over y cubed
Over y,
to the power of 3.
no.
No, to the power of 2.
Yeah, over y squared, right? So because instead of y to the negative 2 on top, we can move it to the bottom and make it y squared. So with that one, we just should be careful that we don't write y to the negative 2 because they asked us for all positive exponents. Questions about this problem or this type of problem?
Nope.
Okay, test will be on Friday. 39 is due tomorrow. Let me tell you which one's due for 40. Then I'll hand out the sheets.
2 sets are due.
Yes.
Wait. 2?
Yeah, because I left it at my house, but I did it. Wait, what?
Oh gosh.
No, bro, 39 due tomorrow. I'm assuming 40 is
They're both due tomorrow.
What?
Goodbye.
Goodbye. They're due tomorrow.
Sometimes